So we're going to do the first derivative test with f of x equal to x to the fourth plus 1 all over x squared. And at this point, I would ask you to pause the video, try to find the derivative on your own, and then follow along from there. So when we do find the derivative, we get f prime of x is equal to 2x to the fourth minus 2 over x cubed. And in the first derivative test, just like everything we've been doing, we need to find the critical numbers. That's when the numerator and denominator equal 0. So 2x to the fourth minus 2 equal to 0. X to the fourth equals 1. So x is going to be a positive or negative 1. On the bottom, we get x equal to 0. So what we want to do then is create a number line. Put our critical numbers on the number line, -1, 0, and 1. And when we're analyzing here, we can also picture what's going on in the real graph. On the original graph, x equal to 0 is undefined, so we have an asymptote there that we can look at. -1 and 1 are defined, so we'll figure that out later. But let's pick our test values. So my test value is going to be -2, -0.5, 0.5, and 2. And so I need to evaluate these for the first derivative. So f prime of -2, f prime of -0.5, f prime of 0.5, and f prime of 2. And we're just looking for values. Is it positive or is it negative? It's positive, it's increasing. If it's negative, it's decreasing. So when I plug -2 into this derivative here, I get a positive on top and a negative on the bottom. So it is negative. So that means my graph is decreasing to -1. For -0.5, when I plug that in, I get a negative on top with a negative on the bottom, so that is positive. And again, pause the video, check the calculations on your own to double check that they're correct, but that is in fact increasing. When I plug in 0.5, I get a negative on top, but I get a positive on the bottom this time. Negative divided by a positive is a negative, so I am decreasing after this asymptote down to 1. And then when I plug in 2, I get positive on top, positive on the bottom, which is positive. So now I increase. So it looks like at -1 and 1, I have minimums by the first derivative test. But you do need to plug them back into the original in order to tell if they are what the coordinate is on the original graph. So f of -1, when plugged in, gives me 1 plus 1, which is 2 over 1, so I get 2. And f of 1, I also get 2. So I have relative minimum at f of -1 and f of 1.